Lambda expressions were introduced in Java 8, which seems like forever ago, but they still seem like a really misunderstood topic. In this video, I'm going to show you how they work using Java's built-in functions first, and then I'll show you how to build your own. You're going to have to be brave and persistent. We're going to get to Lambda expressions, but I'm going to take you on an adventure so that you can understand and remember the weird syntactic sugar that they are. Once we have that, I'll show you a bunch of classes that Java gives us to help build them. For example, let's say that we have a simple class that holds some information about animals and a class that processes lists of animals. For example, maybe somebody wants to print out all of the dogs in a list. Pretty easy to code a method for that. Then somebody wants one that prints out all of the old dogs. Still easy, but how many of these are we going to have to build? If there are going to be a lot of these, I'd really like the person calling the method to be able to pass in the condition. That's the kind of thing that we can do with Lambda expressions. Java gives us a class to carry the code that is essentially a conditional, the predicate class in java.util.function. Basically, it contains one abstract method called test that every concrete subclass must build, and it has a generic that tells it what type of objects will be passed into that method. So, we could build our print method to take a list and an instance of predicate of animal. Then, it just calls the test method in that to determine if a given animal should be included in our printout. Well, that's pretty slick. As a first pass, we can build a dog predicate class that implements predicate with our generic being animal. All we have to do is build the test method that contains our condition. Then, anyone can print dogs like this. And remember that our print method is using that test method of the predicate to decide which to print. If we used that predicate lots of places, that might be a great solution. But building a whole class, even if it's private, is pretty cumbersome. And it puts our condition far away from the code that's using it, which isn't very readable. So let's build that as an anonymous class right where we need it. This syntax creates a class that has no name. That's why they're called anonymous classes. But we know that it extends predicate of animal. Just like when we build dog predicate, this class has to build the test method. So we put our condition in there. The new shows that we're making an object of that class to pass into our print method. Comparing these two solutions, they pass equivalent objects into our print method. The only difference is that I could reuse dog predicate. If I did this in lots of other places, I'd have to copy and paste that anonymous class. That'd be icky. But there are lots of times that we only want to do this in one place. Then the anonymous class is much cleaner. Our code is right where we're using it, and we don't have to wander around to understand what's happening. Going from the anonymous class to the Lambda expression depends on the fact that predicate only has one method that we have to implement. In Java, an interface that requires only one method is called a functional interface. That simplicity is what lets us use the Lambda expression syntax. All Lambda expressions do is to simplify this anonymous class syntax for functional interfaces. The Lambda expression syntax takes advantage of two things. First, the compiler knows that our print method requires an object that is a predicate, so we don't need this. And since predicates only require us to write one method, the compiler knows what method we need, so we don't need all of this. And we already know what type the parameter has to be. So the Lambda expressions require the parameter list, so that we can get to name that variable, and the meat of the method, and a rocket operator connecting them. These two pieces of code say exactly the same thing. And if we only have one statement in our method, we can simplify this one more time by getting rid of the curly brackets. So our first requests to print the dogs and to print the old dogs is built with these two lines of code, which call the print method in our animal facts class. Remember, this is building an anonymous class that puts this piece of code into the one required method of predicate class, We can only use the Lambda expression syntax with a functional interface, and that's an interface that requires only one method to be written. In addition to predicate, java.util.functions has a bunch of other functional interfaces. That list is long, but there are patterns here to make it make sense. First, the types in their generics are clues. T and U are always inputs, and R is always a return type. Second, all of these fall into 4 basic categories. Predicate. This is the one we know. It takes input and returns true or false. Consumer, which is a unary function from a given type to void. It takes an input and does something, but it returns nothing. Supplier, which takes no input and returns something. And function, which takes an input and computes a result. The rest of all of these are more specific interfaces in those categories. For example, consumer, function, and predicate can take 2 arguments if you use by consumer, by function, and by predicate. Binary operator is a specification of by function where the 2 inputs and the output are all of the same type. Then, all of the ones that contain int, double, or long in their names are allowing you to use those primitive types as arguments or return values instead of using an object. For example, int consumer takes an int and returns nothing. Long function takes a long and returns an object. If there is a 2 in the name, the types before the 2 are parameter types, and the type after the 2 is the return type. For example, long to double function is a function that takes a long and returns a double. And too long by function takes 2 objects as parameters and returns a long. This can also be combined with obj for object if one parameter is an object and the other is a primitive. So obj_int consumer takes 2 parameters, an object and an int. Why did they do this? Well, apparently, these general-purpose functional interfaces are used by the JDK, so they made them available to developers too. For the vast majority of situations, one of these will provide the framework you need to allow someone to pass code snippets into your function, like we did with predicate, and will allow the code that calls your function to use a Lambda expression, because all of these are functional interfaces. If you need to, you can also build your own functional interface. The only rule is that it can only have one method that needs to be built by classes that implement it. Maybe you need more information passed into your function than the general purpose functional interfaces provide. No problem. Define your interface, make it the type of your method's parameter, and use a Lambda expression to pass it in. For example, suppose I wanted a predicate that checked all of the fields in the animal against given values. My interface's functional method would take 3 parameters and return a Boolean. I could build my method in my animal facts class that builds a list containing all of the animals that the predicate said matched. And then I could use that method to gather all the dogs named Fido that are older than 10 with this Lambda expression. So, a functional interface requires only one method to be written by the classes that implement it, and they let us pass snippets of code around. There are 3 ways the caller can pass the code into your method. Explicitly implement the interface, like we did with dog predicate, implement an anonymous class, or write a Lambda expression, which is just syntactic sugar that simplifies how we code that anonymous class.